choice what you want to focus on. I'm just not sure they won't put these topics that are calculated here on the non-calculated portion. So just going to cover them all. So it says the rate at which cars enter a parking lot is here, and the rate at which cars leave is up here. It says both of them measured in cars per hour from time 0 to 12. 5 a.m. is time 0. So what's the rate of change of E of t? So they want E prime of 7. Again, if I enter E into my calculator, which I have already done, all I have to do is second calculate derivative at 7. And I don't have to be able to see the picture as long as I can, as long as I have at least 7 in my span. And then it says, if this is in cars per hour, this will be in cars per hour or cars per hour squared. It says how many cars enter the parking lot from time t equals 0 to t equals 12. Well, this is the rate at which cars enter the parking lot. So this will be the integral from 0 to 12 of E of t. Now, if I do this on my current window, I am going to get a error. So I'm going to make sure my window is at least through 12. Makes sense to go 0 here. So I'll go second calculate 7. Again, I won't see this picture. If you want to, hit zoom fit, but I don't really care. If I do that, I get 520 cars approximately enter the parking lot from time 0 to time 12. Part C says use a trapezoidal sum with 4 subintervals to indicate the data in the table to approximate 2 to 12 of in L of t dt. So I'll do a left hand and a right hand, and then I'll just average those. So I'm going from 2 to 12, 4 subintervals. So I'm going to go from here. Okay, so I'm going to go 2 times, sorry, hard to see it from here, so I'm going to fold this up. So I'll go 3 times 15 plus 4 times 40 plus 2 times 24 plus 1 times 68. So that'll be my left hand. So I got 3 times 15 plus 4 times 40 plus 2 times 24 plus 68. So my left hand guess is 321. Right hand, I'll do 3 times 40 plus 4 times 24 plus 2 times 68 plus 1 times 18. So 3 times 40 plus 4 times 24 plus 2 times 68 plus 18 gives me 370. Then I'll take 370 plus 321, divide by 2. So I get 345.5. Then it says, using this, explain this in the meaning of this in the context of the problem. So that would be the number of cars that have, what's L of t? Cars leaving. So that's the number of cars that have, approximately number of cars that have left during that amount of time. And then D says from 0 to 6, $5 are collected for each car entering the lot. From 6 to 12, $8 are collected. How many dollars are collected from the cars in the parking lot from 0 to 12? So I'll do 5 times integral from 0 to 6 of E of t. And then I'll do 8 times integral from 6 to 12 of E of t. So let's go back here. So we'll go, oops. So we'll go second, calculate 7, 0 to 6. So we'll go 5 times 210.141. I can write, I promise. Plus 8 times, and I'll do the second, calculate 7 from 6 to 12. And that's 309.929. And then I'll just run these calculations. So I'll do that answer times 8 plus 5 times 0.141 I'll get $3,530 is the closest dollar figure since they want it to the nearest whole number. Okay. All right, guys, I'll catch you on number 2 here in a minute.